Welcome to clickmyproject.com. Our product title is Open Loop Fractional Division using a voltage comparator based digital to time converter. Now we can discuss about our product abstract. In our process we can generate a variable delay control by a digital word of implementation of DTC chain inverters in the digitally controlled capacitors. In the value of delay controlled adjusting values capacitor loadings inverters, this DTC technique supports the power hungry of the power consumption increasing linearly with the higher resolutions. In our process we can reduce the area of and considerable the enable of operations in the low frequency of the needable large capacitors values, and then we can implement the architecture of DTC process, the new architecture of voltage comparator on integer and voltage digital to analog converters. This process we can produce the desired delay and operation of the DTC process, the inverting version of input signal integrated by the integrator the produce the ramping signals. In our process the corresponding digital process desired delay and output of comparators depending on the value of different delay values. We can achieve the delay values the different value of respectively the maximum power of the value the avoid to the non-linear regions. It's very important of the nodes for the delay maximum at the limit of the input clock periods and depending the constant of the maximum values. And then process the consist of the conventional fractional divider follow the DTC and discuss the process of the relocated the edge of the output clock in the desired location of eliminate processing the clock, and we can implement the integration of the value of maximum variation of and desired delay of process. We can corresponding the certain change of the delay time produced by the comparator the maximum clock and the value of delay process. The open loop fractional divider using the two limitation of through introduce the feedback structure of the two clocks of generator, the exact difference of one input clock cycles, another the clock difference is used in the reference clock value in the delay. Let me see our process flow diagram. In our process we have designed the comparative process. First we have designed the CMOS design. In the CMOS circuits are constructed in the such way of the all PMOS transistor must have either an input from the voltage source or from another PMOS transistor. Similarly, all NMOS transistor must have either an input from ground or from another NMOS transistor input from the ground. The composition of PMOS transistor creates low resistance between its source and drain contact. When a low gate voltage is applied and high resistance, and when high gate voltage is applied on the other hand the composition of NMOS transistor creates high resistance of between the source and drain. When a low gate voltage is applied and low resistance when a high gate voltage is applied. After this process completed, we can go into the architecture design. In the architecture design we have designed the what are the process we have NMOS and CMOS, and using the PMOS process is designed. After going to the comparator process, and comparators is a device compared to voltage or currents and output of the digital signal. It has two analog input terminals and one binary digital output. Comparator consists of a specialized high gain differential amplifier. They are commonly used in a device measure their digitized analog signals such as analog to digital converters as well as axis and oscillators. After we are going to DTC process. The DTC process of double tile design process. Comparators are compared the terms of their power, delay, speed, rise time, fall time, average time. The double tile enable both loads current for fast latching of input common mode voltage and a small current in the input stage for low offset. The accuracy of comparator, which is defined by its power consumption on power, is an in or interest of achieving the domain of signal processing with low power in our ADC systems. After going to the process finished, we are going to the bipolar design. The bipolar CMOS offer high speed and high gain, low output resistance, which are the excellent properties of high frequency analog amplifiers, and the CMOS technology offers high input resistance and is excellent under construction of simple low power logic gate. The bipolar process combined finished after going to the comparator checking. The comparator checking in the CMOS technologies is a combination of bipolar and CMOS technology. The CMOS technologies offers less power and a smaller noise matching bipolar logic. Another hand of the high switching process, we can create the process. Then we comparing the what are the best one, we can get the analyzing performance and we get the output for the process. Let we see our process running procedure, and we can implement our process comparator DTC process using the TANA EDA 13 version. In our process, we have designed this is we can hide the process, and then we give the some instruction for the how to run the setup simulation setups and how to run the process. First we can explain the for how to set up the slice simulation process. We can choose the transient and foreign analysis, and then the time setup. We can make the time maximum time and the starting time and stop time. We can give this process whatever may be the time. Some we can give the 100 ns to 600 800 whatever may be given. After this process completed, we can go to for the cell create. Cell also process a new cell. We can create another cells. First we can give the input process of cell 0. After the processing elements of parameters value changing the write and read process, we can make it the cell process. And I have designed the first cell 0. We have completed process, and then go into the library setup process. The setup simulation process, we can go into the library also. So whatever we have store the process in the libraries located, we can give the path same locations. After giving the process, it will be run the output, we will get it. So now I am going to the running the process. It will be get the w edit the waveform generation of the process. So output is giving the comparator process. The comparator mainly we can give the process, so voltage and current whatever maybe we can give the process. In the comparating the process, generally it will be give the high gain process voltage and current voltage. So maximum value we will get it the comparator value output process. So automatically we open the w edit process. We can give the processing the will you open that. So this is the process. So we can give the split the values of this is the process, and then it will be the give the input for the make it the 0 and 1's triangular value. This is 8-bit values. After we get the value for the this process clock and input value output values, so we make it the same value for this output process. So in the process we can split the input and the voltage output and the clock pulse we have varied. After this process we completed, we can go to the process the timing, what the time maximum time it will be take it the process 2.6 seconds process output. So we can comparing output overall the processing elements output timing elements. Thank you for watching our video.